Our next speaker is already up on the stage, Dick West. Dick has been the technical director for exploration for Lundin for the last 10 years. He's got his BSc in geophysics from Montana Tech and an MSc from the University of Utah. And he worked for various service companies in BHP Billiton for a while, exploring for geothermal, petroleum, and mineral resources, so a bit of everything. Hey, Dick.
Well, good morning, everybody. My throat's a little funky today, so hopefully it'll last out through the presentation. Exploration around Neves, Corvo, and within the Portuguese pyrite belt is germane to this discussion because, for one thing, Neves Corvo was one of the original deep exploration discoveries in the area, and much of the Portuguese pyrite belt is covered either by thick sediments or worse, conductive sediments which aren't as thick. So it makes it a very challenging environment to make discoveries in the area. I'm going to talk about, well, my talk is too long, so I'm going to really cut through the geology and get more to the geophysics. So very briefly, the geology, even briefer on the history, and then get into the experiences that Lundin Mining had in the last 10 years in the belt and the success that was had there. Oops. So the geology of the area, the location is, first off, it's located within southern Portugal, extends over into Spain. It's 250 kilometers long, and it varies in width from 25 to 70 kilometers. Most of my focus is going to be on the Portuguese pyrite belt, which of course is the portion that's in Portugal. There's three basic units in the area that we have to be concerned with. The first one is the shale and the greywacke, which is this gray zone in through here. Then you've got the volcano-sedimentary complex, which we'll refer to as the VSC because it's just easier. And that's in this paler fuchsia color, which extends over into Spain. And the last unit is the effective basement, the PQ, the phyllite and quartzite unit, which is off mostly to the north. You'll notice straight away, well, while we're talking about this, the South Portuguese zone rammed into the Iberian terrain. And from this collision, then this gives us a fold and thrust belt. So up near the collision zone, you've got the bedding, which is more steeply dipping. It dips to the northeast, and you also have thrusting. As you move away from the stress point, then you get more into open folds, but still some thrusting in the area. So that definitely causes complications for exploration, this thrusting. You'll notice that these red dots scattered around here, those are the 90 deposits that have been discovered in the area over 4 millennia. So the area has been explored for a very, very long time. Most of the effort sort of stopped after the Romans. They were the most organized, and once the Roman Empire collapsed, then exploration pretty much died in the area until the 19th century. 2 more discoveries were made in Portugal, and then it was another 100 years till the mid-50s before there was another renaissance of discovery in the area. And probably most of you, a lot of you would know this. I'm actually curious, this will give me a measure of how honest I have to be, is how many people here have worked are in the Portuguese or the Iberian belt or on data sets there? Would you raise your hand? Yeah, a lot. Okay, so I'll keep it honest then. It is a prolific belt. There's 1.7 billion tons of reserves in this area. Almost 2 billion tons. So it's a phenomenal area. And of the 4 largest deposits, Neves Corvo is the second largest deposit in that area. So it's a nice prize to have. The stratigraphy, go over it really quickly. The stratigraphy is simple, but it's complicated by the structure in the area. You start out at the BA Flysch group at the top, then you get into mudstones, siltstones, and wackies, and they can be pretty thick. Then there's a thrust fault, and you go right back into the BA Flysch group again. The next and more interesting formation is the VSC. In the VSC, you've got mudstones, rhyolites, and I'm going to be talking about really around Neves Corvo. So around Neves Corvo, it is predominantly rhyolites. You don't get much of the mafic volcanics in there. And then up near the top of it, you got the massive sulfides and the feeder stockwork into it. The phyllite and quartzite, the PQ, is in the basement rock, but when you're drilling out there and you hit PQ, you're never quite sure, is that really basement, or is this just another fault sliver that's come up through a thrust, and there's more prospective rock underneath. The geology of the area is dominated by an anticline, and this is the Rosario Neves Corvo anticline through here. The flysch is all this white. It's just a sea of flysch and gray wackies out there. Then you get into the shales in this lighter brown. The fuchsia is the felsic volcanics, which dominate this southern portion here. You do get a little bit of PQ that outcrops there, but there's really not much PQ in this area. And then it's up in the northern portion that you get the mafic volcanics, and also on the side. So remember these three fingers sticking down through here. And just to look at a bigger, broader picture, those are the three fingers we have here. There's a northern belt, which is called the Northern Thrust Belt, and there's another longer name, but we'll just use Northern Belt. And this is also prospective ground in this area. Now, I've already forgot to mention one thing, and that's in 2007, Lundin Mining, in 2006, towards the end of that year, we picked up Eurozinc and got this project, Neves Corvo, and the land around it. So this was our tenement position, and we had 5 years to explore it and basically cut out all the ground that we weren't interested in. So that's a huge area. That's most of the prospective ground, at least in the flysch area. And that was quite a daunting task, and we'll get into that later on. Historically, as I mentioned, it's been explored for a really long time. In the 50s was this renaissance. And the thing that should be the takeaway from here is that spatially and temporally is where you get these clusters of deposits found. So starting with Moinho, around Aljustrel. Aljustrel is right there in 1955. That was the first sort of New Age discovery in the mid-50s, 1955. And then you found Feitage, Estacao, and Gaviao around it. Then Salgadinho was found. Then Neves was found in 1977. And then you had the whole group of deposits in the cluster of Neves Corvo. And then that went back up to Lagoa Salgada, which was a gravity discovery and an MT discovery. And then that basically, we ended it off there in 1992. So there was this really prolific period where a number of discoveries were made, and then everything went dormant again for another 22 years before the next discovery was made in the Portuguese Pyrite Belt. So focusing in on Neves Corvo, Neves was found first, then Corvo, Graça, Zambojal, Lombador, and then Semblana, the inverted boot, and that was in 2010. So there was quite a gap between Lombador and Semblana. And while we're talking about Semblana, the inferred mineral resource is 7.81 million tons at 2.91% copper and 25 grams per ton of silver. And if you took all the metal that's expected to be mined in the area, plus all the stuff that's been extracted, there's more than 3 million tons of total contained copper. So this is bigger than most porphyry copper deposits. I mean, this is a fabulous deposit. So let's look at the first discovery at Neves. They started drilling in the area in 1969. They had done a gravity survey, 100-meter grid, geologic mapping, and then they decided from looking at the gravity, there were 10 high-priority gravity targets, and Neves was one of those targets. Here's the gravity profile up here. You've got about a half milligal anomaly. The interpretation done by the geophysicist was it's probably the excess mass 50 to 120 meters, 150 meters down. So they drilled the hole. They went past 150 meters because they were still in the prospective VSC. And At 240 meters, they went into the coombe, which is, of course, the overlying sediments. So they stopped the hole, pulled out, and they went on to these other targets that were on their list. But the geophysicist, of course, said, well, we didn't explain this anomaly. The results don't explain it. So from doing additional drilling, mapping in the area on these other targets, they learned a lot about the geology and about the complexity of the structure, which is what had confused them there, and also about how thick the bedding was in the area. So with this new knowledge and this much improved geologic model, they came back in 1976, looked at this gravity data again, and reinterpreted it, and they said, okay, it's much deeper. So they finally got funding for this second hole, and they drilled it, and at 350 meters, they hit massive sulfides, 53 meters of it. So the takeaway from it was that, if you first don't succeed, don't give up, just keep, learning and keep reapplying that learning to what you already know. And in this case, improving the gravity model allowed them to make the discovery. Everybody has, well, not everybody, but a lot of companies have worked in this belt, and they've done I think every standard geophysical technique has been applied here in desperation to try and discover a new deposit in the area. But gravity, of course, had a special place for most people because it had made a discovery in the area, a nice covered discovery. So in 2006, Eurozinc was working in the area, and they asked Dennis Woods to pull together all this gravity data that had been done by all of these different companies. So there were hundreds of surveys from regional down to small project scale. So Dennis worked through it, created this really nice image of the gravity data for the region, and it was you can see here's the three fingers again. Here's the anticline coming down. This is the Neves Corvo area, a large sort of regional gravity anomaly. And the northern belt, you see lots of texture from the steep bedding in that particular area. But once you get into the Flish, which is this area and through here, there's just really not much character that shows through. There's not much you can drill target off of that. So in 2007, Lundin Mining came in, and one of the things that was done was an airborne FTG, airborne gravity gradiometer survey, to help fill in the gaps in through here. And so that was done, and a review of all the geophysics that had been done in the area was also done. So it was decided that to a depth of probably 400 meters, if there was going to be something big out there, it probably would have been found. And what we were going to do was try and find something big. So the target then was, all right, we want to explore between 500 meters and 1 kilometer, which is a pretty tough ask because there are some shales within this section which are conductive. So no airborne survey at that time could do that type of exploration for us. So then we were left to doing just groundwork. So what was decided to do was to do a fixed moving loop survey. So each one of these squares you see up here is a kilometer by kilometer loop of wire, square loop of wire. And within that square loop, 50 stations were done, TEM stations, 2-component, at 50-meter spacing within that loop. And then you do a 1D inversion on each one of those stations, and you'd stitch all of those together to produce a geoelectric section. And you could do that in this area because we're still out in the fold belt, so things are dipping 45 degrees, so 1D inversions do a pretty good job of matching up with the geology. So you can see we did quite a set of these loops, and it took us 5 years to grind our way through that. And just to be complete, here's the MAG. It doesn't show you much. The mafics show up, and that's about it. So here's the 1D section that we did at Lombador. First thing we had to do was do an orientation survey. We went to Lombador. There's a formational conductor, which is the Neves formation, which sits right above the mineralization. So that was actually pretty good. And here's Lombador. And you'll say, well, that looks pretty crappy in through there. And unfortunately, this isn't the nice looking sections that we got at Lombador. I'm only showing this because we had a seismic line over this, and so it's for comparison. But actually, we got a really beautiful anomaly with Lombador. We were very happy with it. And we were getting down to 1,800 meters with the conductor with this representation. So we were also happy with the depth of exploration we were getting. This is about 1 meter, this warmest color here, and this is resistivity, so it's a flip scale, so warm is low resistivity. In 2006, with this gravity data set, Eurozinc sent the data to Mirror Geoscience. They did a constrained inversion on the gravity data set. And what they did is they had physical properties, they applied average densities to most of the section, and when it came to the VSC, they allowed that to float. And so they would get variations in density only within the VSC, because that's where we were looking for the massive sulfides. It shows a nice, this is a shell, anomalous shell, 0.2 grams per cc. It runs right along the crest of the anticline, and then it turns east and through this area. Of course, we didn't know Semblana was there, but Semblana sits right in that zone as well. There's another zone down here. Much of this had been drilled out and nothing showed up, so the geologists weren't too excited about the representation. But it was recognized that this area was interesting, so we ran 3 lines of this moving fixed loop through it. Here's the results for that. Here's the formational conductor here, using the same color scheme as we saw with the Lombador deposit. This is only about 60 ohm meters, which isn't really that conductive. The shell is situated here, that 0.2 shell, and the two overlap, but they're not coincident. Semblana is located right there. So it was decided, and you can blame me, I said this is a second priority target, it's not conductive enough, the two things don't overlap, so let's move on and find something better. In 2009, we had a geologist join our team, and he looked at the lithologies out of the drill core and basically redid the map in this area. There wasn't much drilling, but with what he had, he redid it, and he came up with that the mine horizon, this Neves formation, extended down into this area. And not only that, but it was at the same depth as the resistivity anomaly at the base of it and this gravity anomaly. So when you put those three things together, now this made this more interesting. So the project geologist and the regional geologist, they looked at that and they said, this is a high priority target. So they went, of course, circled it on the map and got it promoted up to a high priority target so we could drill it that year. And then, because of the way things are with discoveries, that piece of ground was transferred from the regional team to the resource development team, and they were going to follow up with the exploration on it. But they were busy doing Lombador, drilling out Lombador, so it was going to be a year before they got around to doing any drilling there. So now it's 2010, we've got a year left, we've got still lots of ground to cover. A ZTEM survey was done in this area here, there's Neves Corvo. 2D sections were done, an Occam inversion result was done, and we got, in this particular one, you can see conductor, again, it's an inverse scale where the warm colors are the conductors. Got two subparallel dipping to the northeast, just like we expect. That all seemed good. We would do follow-up with ground EM, just as we did previously, and those conductors are traced onto here. So we got good correlation between the two. I would trust the 2D inversion in terms of dip over the 1D, because now we're dealing with a much steeper dip in this area. But we were quite happy with it. And using that, we went through, screened off all the interesting areas, and then drilled off the ones that were good for us. And then we were done with it, and we dropped the ground that we weren't interested in. So we were able to achieve our goal in the 5 years. 2010 was really a busy year. And I'm not, forget that slide. It's like a Monet. And then the discovery, in the summer of 2010, two things happened. I contacted HiSeis, HiSeis was contacted to do a 3D seismic survey in the area, and the resource development team got around to drilling off this. So they picked 3 drill holes in advance, permitted the locations, and went out and drilled them. The first hole, there was nothing really of interest in there. We were doing borehole TM in all of these surveys, 3-component. Then when they got to 44, this is the borehole survey results from that. Each one of these is from 500 to 1,250 meters in depth down the hole. The scales here are log in order to be able, because we had so much difference in amplitude here, had to go to a log scale, but the scale is the same for each one of these. Here you can see the in-hole, which is this formational conductor. Then it drops into a negative, which is indicative of an off-hole anomaly, which is what we were looking for. So we were happy about that. Not only that, but the in-hole anomaly was pointing in this direction, and when you got to the off-hole anomaly, it was pointing towards Semblana. So we went to the third hole, drilled that, you got an even stronger in-hole anomaly, much better, and now it's pointing back towards Semblana again. So we knew there was something in between those two holes. They picked out a target drill hole, SO48, drilled it, and intersected 5 meters of massive sulfides, which was barren, but that was the discovery of the Semblana deposit. So it was a really good story, had all the suspense and things that you get with a discovery, and so it was really a wonderful thing. Okay. In 1996, seismic survey had been done in the area. It went across Lombador. You can see Lombador shows up well. Geology is horrible. In talking about high size, we did physical property measurements on the rock just to verify that, yes, we could actually get reflectors off of it. And the massive sulfides and stockworks, their acoustic impedance is much higher than everything else, so we were pretty happy with that. Also did synthetic traces by doing borehole wireline logging, because you need that to really get the information to process your data. And from that, we could verify that the synthetic traces generated from the borehole data matched the traces that we got out in the field, so we knew we could image the data sets. There's the survey. It was a 4 by 6 kilometer area. We used a Vibra-sized truck for most of it, and then a weight drop machine for the other area. You have to break it up into patches. You can't do it all in one shot. So there were 28 patches. They were orthogonal. There are 10 source lines, 90 meters apart, and 11 receiver lines, 11 meters apart. Geophones along the lines, 15 meters. Sources along the line was 45 meters. And we knew we could get down to a depth of 2 kilometers because we had a good fold density in the area. So there's the review on the 1996 data set. And here's the data set from 2011. This is a slice out of the seismic cube that was delivered to us. And here you can see, Lombador shows up really well in through here, and we've got much better geology showing up from this. So we'll be able to extract a lot more information out of it. It's not just a target detection tool, it's also geologic mapping, which will help us with the structure in the area. So forget that, and we'll jump to this. And here you can see the reflector. Well, we've got the red deposit shown in red, sitting on top of the reflector, which is red, so it's kind of hard to see, but just the two of them lie right on top of each other. So this is Lombador. It's dipping at 45 degrees, so when you take a horizontal slice through it at 850 meters, you're only going to see an edge of it, and that's exactly what we see here. Very strong reflector. It's the strongest reflector we've got out there. Semblana is flat-lying, and the deposit itself sits right on the red reflector that we get off of that as well. So that was also an excellent. And if we didn't know where these two deposits were, those would be the first 2 places that we would drill because they were such strong reflectors in the area. So here's a slice, vertical slice showing Semblana. That's obviously the Semblana deposit, and if you put the deposit on it, it fits right over it. So we were extremely happy with this orientation survey. And I only wish we'd done it the year before so we could have made the discovery with seismics rather than just more conventional approach to it. The conclusions are the ones that you would expect from any of this. You need to really combine geology and deep penetrating geophysics in an area, and you've got to have the physical properties so you can really match up the geophysics with the geology and actually image geology with the geophysics if you're going to get the most out of your data sets. 11 deposits in 37 years. It was 22 years before Semblana. Geologic models combined with the gravity were an important tool early on in the Portuguese pyrite belt. But for the future, looking ahead, it's going to be time domain EM and it's going to be seismology that are going to be making the discoveries because we're going to be looking deeper. We're also going to get into more complex geologic settings. So Semblana was done by persistence, geologic model, revised geologic model, sophisticated modeling of the gravity data, EM anomaly combined with this borehole TEM. Thrusting and plunging of the prospective VSE underneath the Greywackies makes it a difficult area to explore, but that's also why you should be exploring there because it's also, ripe for discovery. And 3D seismics and 2D seismics will be the way of the future. And if you look forward, it's basically the same thing. You've got to combine geology, geophysics to winnow out your areas into area of interest, generate targets, and if you're not happy with the targets that you're getting with traditional geophysics, then spend the extra money to do 3D seismic or combine it with 2D seismic so that you can cover larger areas and do a more effective job of making discoveries. And I'll just go to my prediction. There's going to be more seismic discoveries and more discoveries in the Portuguese pyrite belt. And here's the people that did all the work in this area. Matt and I would like to thank Lundin Mining for allowing us to give this presentation. And here are the significant contributors for Lundin Mining staff in alphabetical order. And here's the recognition of contractors and consultants, because without them, without data, there's no ideas to work on. So thank you. And I don't know if there's any time for questions.
Thank you, Dick. Unfortunately, to keep on time, we do have to move right on.